Okay, here we go. 7.7 exponential growth and decay. Exponential growth, when we see a graph like this is exponential growth. It's growing as it goes from left to right. Okay, we see it go up fast. When we look at this, we've been dealing with this y equals a times b to the x. This value is the starting or the initial amount. Many times they'll call it the starting amount, but it's what you start with is the a value. The other value, b has to be in here. It has to be bigger than 1. So for example, it could be 2. That means it's going to double. Okay? It could be 3. That means it's going to be triple, but it has to be bigger than 1. So it could just be a value like this. It could be 1.1. That's bigger than 1. But it can't be something smaller than 1, like 0.9. So because it's bigger, that then makes it the growth factor. Okay, that's going to be exponential growth. So you're going to get a graph like we see over on the right. On your notes, I think it's over on the left. Okay, so here in our notes, we're going to graph by making a quick table. So if you have your calculator, you take 2 and you raise it to the x. Now, right away, if we said, well, what's a? A, b to the x. What number could be considered out in front here? 1. So that means initially we should start with 1. Okay, but we'll see that as we go. So if we put in -3, 2 to the -3, you put it in the calculator, what comes out is 1 over 8. Now, I would rather you took it when you're doing it this way. It's easier to graph if you make it a decimal. So in your calculator, if you make 1 over 8, 0.125, it'll make a lot more sense. Then we take 2 and we raise it to the -2. Again, make it a decimal. 2 to the -2 is 1/4, but that would be 0.25. Then we raise it to the -1. It's going to be 0.5 or a half. And then we put to the 0. That gets us 1. I'm going to graph that one. And you put a dot 0, 1. The rest of these, you could graph. You could go, this is a half, this is a quarter, this is an 8. And you see how the thing is starting to grow exponentially. And what it's doing is it's doubling. But I want to focus in on this one just for a minute. 0, 1 at times 0. Anything to the 0, this became 1, and we get the value of a out there. We get that starting amount. Now, if you put in a 1, clean that up a little bit, getting a little messy. Anything to the 1 is itself, so that's 2. So we could graph 1, 2 over here. 2 to the 2 is 4. 3 to the 2 is 8. I'm only going to graph this one. I'm going to go up to 3, and I'm going to go up 8. Got a little higher there on the 9. The board's a little off. But then we can graph this function, and we see it growing. It's an exponential growth function. Again, what's the domain? The domain is all reals, the range, the line stayed above 0, so it's y is greater than 0. What happens to the output values as x decreases? As x decreases. X decreasing means I'm going this way. The output values, if I go this way, they get smaller and smaller, or they decrease. What happens as x increases? The y also increases. As x gets smaller, y gets smaller. As x gets bigger, y gets bigger. Okay, so this one says we're going to graph and compare it to the parent function, fx equals 2 to the x. So we already did this one. These are all in there. I'm going to copy them from that last graph. This one, at -1, it was 0.5. It doesn't have all the same ones. This was 1. At 1, it was 2. At 2, it was 4. At 3, it was 8. We didn't do 2 to the 4th. 2 to the 4th would be 16. Again, if I graph this one, I'm going to put it on here. Can't guess very well, everybody. Get it right. I have to guess, and I'm always a little bit off. Sorry about that. 3, 8. So this one. That's the original graph. That's 2 to the x. Now what happens to the next one? The next one adds a 3 in front. So if we do take our calculator and we put these in, so as this calculator's warming up, make sure you have a calculator. We go 3 times 2 to the -1. Here's what you're going to see. You get 3 over 2. I'm going to make this one a decimal. I get 1.5. So in here, I'm going to type in 1.5. Next, I'm going to try the next one. 3 times 2. 0, I get 3. What you're going to notice as we do these, if you type them into your calculator, this one gets you 1.5, this one gets you 3. This is 3 times the amount. This one gets you 6. 2 times 3 is 6. This one gets you 12. This one gets you 24. This one gets you 48. So if we were to graph this one, I'm going to do this one in red just so we see it. This at 0, it's 3 tall. At 2, it is 6 tall. So this one, all that really happens is it zooms up faster. It's 3 times the height of the other one. So if we compare, the comparison is it's 3 times higher. 3 times the amount. What's the domain? The domain is still all reals. The range is still y is greater than 0. Now the next one, if I go back to here, if I type these in your calculator, you're going to go -3 times 2 to the -1 and put a dot in there. And what you're going to get here is -1.5. For the next one, you're going to get -3, -6, -12, -24, -48. I'm just going to confirm one of these. I'm going to put in that last one. I'm going to take -3 times 2 to the 4th. I got -48. It worked. Now, to graph this, At 0, I should be at -3. At 2, I should be at -6. And then we graph this. Now, what's the difference? Well, if we compare, it is what we call reflected on the x-axis. I'll write this one on the board rather than with the mouse. Reflected on x and 3 times the height. It's still 3 times as big as the original if we go back here. The domain is still all reals, and the range now is y is not greater, but actually less than 0 because it's below the line.
Yes.
Okay, next one. It says in this question, if we were to, how would we compare the function f of x 4 times 2 to the x? How would it compare to just regular 2 to the x? What do you think it would be? We're supposed to make a connection. In this last one, when we put a 3 in front, it was 3 times higher. So how do you think this one, if we had a, okay, 4 times higher, that's what it would be, 4 times higher. How do you think this one would compare to that one? 5 times higher. That's it. That's just making the connection. It's 5 times the amount, 5 times the height. Okay? Okay, so this one says graph and identify the domain and range. Now to graph, you can make a little table, but I don't give you the numbers here. So what I suggest is you just pick some easy ones. Like that. Remember, anything to the 0 is 1. Anything to it, the 1 is itself. If we just graph those two alone, 0, 1, and 1, 5, we already should have an idea of how this one would graph. It would look like this. This one is exponential growth. Okay? So what's our domain? Our domain is all reals, and our range is y is greater than 0. The next one. Now, if you want to put in this one, the -1, you're going to get 1/5, or you're going to get 0.2. And that's okay. Over here, it gets really a lot smaller. This one, same thing. Just pick a couple points. I'm going to pick 0 and 1 to start with. Anything to the 0 is 1. Anything to the 1 is itself. The domain, again, is all reals. The range, y is greater than 0. Zero, 1, 1, 4, all reals, y is greater than 0. All of these are examples on this page, or this part, of exponential growth. None of them went down. Okay? And in fact, this whole lesson is only on exponential growth. We're not getting to exponential decay until the next lesson. Okay? Now, how would this, if when we put a 3 in front, it's 3 times taller, how does a half affect it? What do you think? If a 3 makes it 3 times taller, what if you put a half in front? It will be half as tall. Yeah, it's half as tall. Okay, it's shorter. Okay, so we're going to look at this one. If I put in a 0, 1/2 times 2 to the 0. Now, you may need to use your calculator to do this. 2 to the 0 would be 1, but then it's times 1/2. So when you put this one in, it should get you 1/2. So instead of 0, 1, you should get 0 1/2 tall. Then when we put in the 1, 1/2, 2 to the 1, we get 1. 1/2, 2 to the 2, we get 2. Still growing, but comparing it, it's half as tall because we started with only 1/2 rather than starting with 1. Our domain is still all reals. Our range is still y is greater than 0. Now the negative, if you make a little table, if you put in a 0, what you're going to get is -2. Because 3 to the 0 would be 1, times -2 is -2. So at 0, it's actually down 2. When we put in the 1, we'll get a -6. When we put in the 2, we'll get a -18. This one looks like this. It zooms down. So what is our comparison? It is a reflection, and 2 times as tall. The numbers would be a reflection. The reflection, instead of going up like this, it does a reflection. If I take this one that I've got here and I say we flip up, down, that's what a reflection is. So the reflection goes here instead. That's the idea of a reflection. Domain is still all reals. And the range now is y is less than 0. Good. Okay. That's it. We'll have a little assignment on this. Hopefully that's making a little bit of sense.